Okay, so today we're going to talk about 2004 AMC 10B Problem 22. A triangle with sides of 5, 12, and 13 has both an inscribed and circumscribed circle. What is the distance between the centers of those circles? So, if you're not familiar with the Pythagorean triples, you should memorize the first few, like 3, 4, 5, 5, 12, 13, etc. So if you see 5, 12, 13, your instinct should be that, okay, my triangle here is a right triangle, because 5 squared plus 12 squared is actually equal to 13 squared. So triangle ABC, which I've drawn here in the graph, is a right triangle. Okay, so what about the inscribed and circumscribed circle? If you don't know, this is an AOPS Introduction to Geometry, but if you don't know, so the inscribed circle has a center. So the center here, I, which I've labeled I, is an intersection of all of the angle bisectors of every angle in the triangle. Okay, so I is just basically the center of the intersection of my angle bisectors of my angles in the triangle. So what about the circumscribed circle? So that's also called the circumcircle, and it's basically, so the center here is basically the intersection point of all the perpendicular bisectors of my sides. So something like that. Perpendicular bisectors of my sides. So I don't know, approximately something like this. So that's the center, and because triangle ABC is a right triangle, so we know that BC is a diameter, because for a circle like this, any circle, BC is a diameter, then any angle like this subtended to BC is gonna be a right angle. So any angle with its rays having vertices of B and C will be a right angle, and its vertex is gonna be on the circle. So this is a right angle, and so BC is a diameter. So BC is also equal to 13. So we know that the radius is gonna be 13 over 2. So let's just label the center of my circumcircle. So my circumcenter will be O. Okay, so what exactly is the problem one? It says, what is the distance between the centers of those circles? So I want my distance between I and O. Let me just draw that in blue so you know what exactly you're trying to figure out. So we want to know this distance. So what can we do? This distance does not look like it relates to anything. So if we don't know this, then we don't know how we can figure out this distance. We can try to create right triangles. So we know that for an incenter, I is actually equidistant to all sides, because ID, so D is just tangent point of the circle I with center I to BC. So ID is actually perpendicular to BC, right? So ID is actually also the radius, and we also know that IF is so perpendicular to AC, because F is this point here, which is, well, it's it's the point where circle of center I is tangent to AC. And the same thing about IE. IE is also perpendicular to, so IE is also perpendicular to AB. So these three lengths, IF, ID, and IE, are all equal to each other because they're the radius, and they're also perpendicular to the three sides. So the center of the incircle is equidistant to the three sides of the triangle. So we know this, and we have triangle IDO, which is a right triangle. So if we figure out DO and ID, then we can figure out IO, right? So because this is a right triangle, so IO squared is gonna be equal to, so actually IO is gonna be equal to root ID squared plus DO squared. Okay, so we want to figure out ID and DO. So this looks slightly easier because at least DO is on BC and ID is the in radius. So ID is the in radius, basically the radius of the in circle. So what's ID? We want to figure out ID, and in order to figure that out, what you can basically do here is, we know that the area of a triangle, so the area of triangle ABC is actually equal to the in radius ID multiplied by, so the in radius multiplied by the semi-perimeter. So here the semi-perimeter means we have the perimeter of triangle ABC, and we divide that by 2. So we have 5 plus 12, which is 17, plus 13, which is 30. 30 over 2 gives us 15. So ID times 15 is actually the area of triangle ABC. We know that ID times 15 is therefore 5 times 12 over 2, which is 30. So because we know that because we know that AB, so angle A here is a right angle. So AB is the base and AC is the height. So it's base times height over 2, which is 30. So ID is going to be equal to 2. Okay, so we have ID figured out. So that's great. We have one variable that we figured out. So we have 2 here, and IE and IF are also 2. So now we want DO. So we want DO, and we know that BO is actually equal to BO is the radius, the circumradius, or the radius of the circumcircle. BO is 13 over 2. So we want DO. So DO looks hard to figure out. So how about we figure out BD instead? BD, well, it's also hard, but maybe it's a better way. So we can try BD because we don't have a strategy for DO. So let's try to figure out BD, because DO is equal to BO, which is just 13 over 2, minus BD. Okay, so here we're gonna prove a few things. So we want to know that BE is equal to BD. So why is that? So if I just drew this line here, if I connected IB, if I just connect IB, then I know that triangle IEB is congruent to triangle IDB. So why is that? Because I have 2 right angles, this angle here and this angle here, and I have one side, and I know that I is basically the intersection of my angle bisectors for angle A, B, and C. So BI is going to be the angle bisector, or part of the angle bisector of angle B. So these 2 angles are also equal. So we have AAS, angle, side. So triangle IEB is congruent to triangle IDB. So we know that so we know that EB is equal to BD. Okay, so EB is equal to BD, and via the same reasons, we can prove that AE is equal to AF, so AE is equal to AF, and we also can prove that DC is equal to FC. So we have equal side lengths here, and let's just call EB equals BD, and let's just call this to be equal to X. So EB equals BD, which is X. So we have X. Now we want AE equals AF, which is Y. So let's just call this Y. And we have FC and DC to be equal to Z. So we have X, Y, and Z. And we can list out 3 equations for this. And we also have 3 equations with 3 variables. So that's just great. So we know that X plus Y gives us AB, which is just 5. We have that X plus Z. So X plus Z is equal to 13. And we also know that Y plus Z is equal to 12. So if we just solve this equation by, subtracting one equation from another to eliminate a variable. So say if I just subtracted this equation from this, if I subtracted this equation from this, then I'd get z minus y is equal to 8. So z is y plus 8. So if I substitute z is y plus 8 into this equation here, I have 2y plus 8 is 12. So 2y plus 8 is 12, so 2y is 4, so y is 2. So by doing this thing, by repetitively substituting equations like that, we have x is equal to 3, y is equal to 2, and z is equal to 10. Okay, so we know BD, because BD is basically just x. So we know that BD is equal to 3. So we have 13 over 2 minus 3. 13 over 2 minus 3, which gives us 13 over 2 minus 6 over 2, which is 7 over 2. So we know DO is 7 over 2, so that's just great. We can use the Pythagorean theorem here. So IO is going to be ID squared, which is just 4. So that is going to be root 4 plus 7 over 2 squared, which is 49 over 4. So if we just simplify this gives us an answer of root 65 over 2. So for root 65 over 2, this is answer choice D. So we just circle answer choice D and we're done. So the key in this problem here is that we have to realize we want to figure out IO. So we have to draw the graph first, and then we want to realize that how do we figure out IO? Well, there's no better strategy than drawing a right triangle. Or, there probably is, but we can't think of it, right? So let's just construct a right triangle out of sides that look way easier to find than IO, because IO is just a random side. At least DO and ID have connection to our triangle, so we can figure the sides out. And we have to know how to figure out ID, which is just the in radius. So the area of ABC is equal to the in radius times half of its perimeter. And we also know we want to figure out DO. So how do we figure out DO? So DO doesn't look like it's easy to figure out. However, it looks like BD looks a bit easier. So because B is at least B is a vertice of triangle ABC, right? So let's just try if we can figure out BD first. So fortunately we can, because we know that BD is equal to BE, and also AE is equal to AF, and DC is equal to CF. So we have to set variables, and we solve the three equations. We solve the three equations for the three variables. So we have x, and we have to plug x to get DO. And then we have to plug DO into this equation here to get IO. So it's just a complicated problem of solving and also substitution. So thank you.